Good morning to all of you. Myself, Dr. A.V. Raghavendra Rao, Assistant Professor, Chemical Engineering Department, B.V. Raju Institute of Technology, Narsapur. In this semester, I am going to teach Chemical Reaction Engineering 1. In this video, we are going to see the introduction to Chemical Reaction Engineering 1. So in this video, we are going to see what is chemical reaction, what is chemical reaction engineering, what is the importance of chemical reaction engineering in chemical process industries, what student is going to learn in this course, the prerequisites for this course, and after learning this course, what student can able to do. At the same time, we are going to see the textbooks and reference books for this course. What is chemical reaction? A chemical reaction is a process which involves transformation of one or more substances into new substances by formation or breaking the chemical bonds. We can see a lot of chemical reactions in our daily life. For example, combustion reaction where the carbon reacts with oxygen to form carbon dioxide. Similarly, rusting of iron where iron reacts with oxygen to form iron oxide. Similarly, digestion where we are going to have thousands of chemical reactions in the conversion of food to sugar and other carbohydrates. Similarly, photosynthesis where plants makes food by utilization of carbon dioxide, water and light. Similarly, we have a lot number of chemical reactions in our daily life. Chemical reaction engineering. So chemical reaction engineering is engineering of chemical reactions. Here, if you see a chemist can able to produce any chemical in a small scale, that is laboratory scale. If we want to produce the same chemical in a large scale, that is industrial scale, for the purpose of many group of people, for the society, we need to have a large chemical reactor. That means on a large scale, if you want to produce any chemicals, we need engineering. In engineering, that means chemical reaction engineering, we mainly focus on the reactor design to produce chemicals on a large scale. In the reactor design, if you see, we require mainly input, kinetics and contacting. In kinetics, we require chemical kinetics and physical kinetics. Chemical kinetics mainly used for the homogeneous reactions and physical kinetics where heterogeneous phases are involved. Similarly, for contacting, we have mainly batch and continuous. In continuous, we have plug flow and mixed flow. Finally, for the output is a function of input, kinetics and contacting. Coming to the importance of chemical reaction engineering in chemical process industry, you take any chemical process industry, the purpose is to convert raw materials into useful products. If you see all the steps that is involved in the conversion of raw materials to useful products, if we categorize it into mainly three steps. The first step is purification of raw material. That means separation of impurities from the raw materials. Second step is chemical reaction. Third step is purification of product, where we are going to separate the main product from byproduct or co-product. The first and third steps, that is purification of raw materials and purification of products, mainly involves the physical change of the material. Whereas chemical step 2 involves chemical change. The chemical reactor is the heart of any chemical process industry or any chemical process. In a typical chemical process, the capital and operating cost of any reactor is mainly 10 to 25% of the total cost. Whereas the remaining cost mainly goes for the separation process, that is step 1 and step 3. Yet, the performance of the chemical reactor is very, very important because it totally controls the cost. That means it mainly impacts on the upstream and downstream separation processes. In this course, the student will be learning the kinetics of homogeneous reactions, the design of ideal batch reactor, steady state mixed flow reactor, steady state plug flow reactor, single and multiple reactions, parallel and series reactions, basics of non-ideal flow. The prerequisites for this course are the material and energy balance calculations, chemical engineering thermodynamics, chemical engineering fluid mechanics, and mathematics. After successful learning of this course, student can able to classify various type of reactions, The students can able to determine the kinetics of the chemical reaction from the data using integral and differential method of analysis. The students can able to analyze and compare the performance of various ideal reactors. The student can design parallel and multiple reactions. The students can able to compare the performance of ideal and non-ideal reactors. The textbooks for this course is Chemical Reaction Engineering by Levenspiel. The reference books for this course are the Elements of Chemical Reaction Engineering by Fogler and Chemical Engineering Kinetics by James Smith. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.